All right, so we are going to look at whatever day we lectured last. We talked about how energy is continually transferred through a system. And so we are going to look at some of the ways in which energy is transferred and that certain chemical compounds get moved through a system. So biogeochemical cycles are these interconnected pathways through which either water or other chemical elements are continuously recycled through the biotic and abiotic components of the biosphere. So bio, meaning life is involved. The geo part refers to the geology or the non-living or the abiotic components. And I think the chemical is pretty self-explanatory. So we're moving items, elements, or compounds through life, the geology of an area, and chemicals. Okay, they're moving. So there are 3 of these cycles: the water cycle, the carbon cycle, and the nitrogen cycle. And we'll look at each of these in a little bit more detail here. But with all 3 of these, they will all have exchange pools and reservoirs. So an exchange pool is part of the cycle that holds an element or water for a relatively short period of time, whereas the reservoir holds it for a long period of time. Okay, so the water cycle deals with water. The water on Earth is billions of years old. Ooh, I think I color-coded them, so the water cycle will all be blue. The carbon cycle will be, I think, purple, and then the nitrogen cycle is like orange. So this is a global cycle, so that means it takes worldwide. So the water that rains down in Glenville can evaporate and move across the globe before it rains down again. It takes place on the Earth, above the Earth, and below Earth's surface. And water can be found in 3 states. What are those states called?
Wait, like the names of them?
Sure.
Solid, liquid, and vapor.
Solid, liquid, and vapor or gas. Oops. So the solid form of water is referred to as what? Ice. Thank you. The liquid form of water is referred to as water. And Isaiah kind of filled in the gas one. The gas form of water is called vapor, sometimes even water vapor. This little picture here shows you the components of the water cycle. Each of these components are defined on the next page or the next slide. So we are going to be looking at sublimation, condensation, evapotranspiration, evaporation. They don't have sublimation, but we'll deal with groundwater, runoff right here, and an aquifer, which is kind of down here too. So all of these things we are going to be talking about on the next 2 slides. So evaporation is when your liquid water evaporates, probably shouldn't use the same word, changes, oh my goodness, to water vapor, or the gas form of water. This happens in the atmosphere. A lot of evaporation now as our snow melts. The melting turns it to liquid water, and that liquid water is changing to water vapor and entering into the atmosphere. We're really liking this whole evaporation thing. Sublimation is when ice and snow change directly into water vapor. So some of you could probably go home or call your grandma tonight or this weekend and ask her if she or her parents ever freeze dried their clothes. So before we had dryers, like the washing machine and the dryer, people always hung their laundry, clean laundry on clotheslines. Some of us probably still do in the summer. But it works really great in the summer because we have the heat. Yes? The heat helps the evaporation. However, this also works in the winter, not quite as efficiently. But if you were to hang wet clothes out on a clothesline in the winter, over time, that water in the clothes would freeze. So now we have the ice, the solid form. And there are some molecules in those ice chunks, crystals, whatever, that will get enough energy to change directly to gas or that water vapor. And so they will dry eventually. It just takes longer. It was a thing back in the day to freeze dry your clothes. Transpiration is when plants release water vapor through pores in their leaves called stomata. So transpiration is a form of evaporation. The specialty about it is that it's dealing with plants. Okay? We don't say plants evaporate water. They transpire water, transpirate water. And then condensation is the process in which water vapor changes into liquid water. This happens in the atmosphere. And a product of condensation will be clouds. Clouds are made through the condensation of water vapor in the atmosphere. So hopefully this next one, precipitation, I feel like you should be pretty good on. It's a term that gets used in everyday language, and it has the same meaning in science as it does everyday language for once. Precipitation is water vapor that has changed into either liquid or solid water that falls from the atmosphere. I'm hoping you have some examples of precipitation in your mind right now. Yes? What do you got? What are some examples of precipitation? Jorgen?
Hail.
Hail. Good. What else? Isaiah?
Would snow be one?
Snow is one. Very good. Kira? Sleet. Fred? Rain. I think those are the big ones there. So then the last three things dealing with the water cycle is groundwater. Groundwater is precipitation that falls onto the land and soaks into the ground. Right now, we're hoping a lot of our water, remember when it rained, was that last week or 2 weeks ago? And it rained for like a million days straight. And then we got all these fields that are just flooded. That's because that ground is saturated. It literally cannot hold any more water. So the groundwater now has raised or risen above the level of the ground because it was full. You ever tried to put cookies in a container and there's too many cookies, you can't put the lid on it? It's kind of what happened here. The lid, the literal ground we see, couldn't cover the water anymore. So that leads to runoff. That's when precipitation falls on land and then it flows over the surface and it can flow into other bodies of water. And when that happens, that runoff can pick up sediments or chemicals that are in that land, in the soil or in the grasses, and carry them now into our bodies of water. And so down here, A lot of our lakes and rivers get really full of algae here in the spring and summer. That's because the runoff is carrying farm chemicals and yard chemicals into these bodies of water. And a lot of these chemicals are designed to help plants grow. Well, one of your aquatic plants that can grow really well with these chemicals is algae. So we get these huge algae blooms now in our water down here because of all of this runoff. Aquifers then are underground layers of rocks that store water. Sometimes this can happen for thousands of years. So any time you turn on the faucet, you get water without even thinking about it, right? It just happens, which is great and super convenient for us. But how does that water get to you in the first place? So what has happened is some geologists, some scientists has found an aquifer, a rock that is holding water. So think Rubbermaid container stored underground, but instead of Rubbermaid, it's made out of a rock. And they've drilled into it, and now they have a well and a pump system that pumps that water to all these water municipals, water factories, so to speak. Not like a Dasani or Aquafina kind of factory. Well, that makes me think of like making wine or vodka, but there's water treatment centers, and so then once they reach there, they clean out the water, make sure it's safe and healthy, like not toxic, to drink. And then some bigger cities store that water in what's called a water tower. You familiar with those? Glenville doesn't have one, do they? Yeah, they do? Oh, Frost does not. Oh, it is, you're right. So that water is then stored, and then you turn on your faucet, the water gets released and shows up at your house. There is tons of underground water piping worldwide. Not really worldwide, because there's some countries that don't have running water. So there's actually concern because these aquifers can dry up. Okay? Some aquifers can't get any more water in them. They're impermeable. The water there is there. If it gets used up, it's going to be gone. There's no way to what is called recharge those aquifers. Usually to recharge an aquifer, it rains, the water infiltrates the ground, enters into the aquifer. Bam, it fills back up. But there are places like, I believe it's in Georgia and Alabama, that kind of area of the United States, they're running their aquifers dry. And so they're having to transport water over hundreds of miles so they can have the same comforts of turn the faucet on, bam, there's water, that we experience every day and that they are used to. Okay, so now, I lied about the color. The carbon cycle is the interconnected pathway through which carbon is recycled through biotic and abiotic components of the biosphere. So again, here is a brief diagram for you. This one's a little bit more wordy, but we'll go through it. So flowing water can dissolve carbon, and this ends up in the water, specifically the oceans. So in Minnesota, especially southern Minnesota, we have a lot of limestone and calcite and dolomite. And these are all types of rocks. And all of these rocks contain carbon in some form. Carbon is an element that makes up all three of these rock types. And all three of these rock types are very soft in terms of rock. And as water touches them, it dissolves out some of the carbon. And then the water now is carrying or holds that carbon. Like put salt in water, that's water has dissolved the salt and the water carries the salt particles. Same thing can happen with carbon. And so what that happens in Minnesota is it can create caves. It can create erosion if that calcite or the limestone is around a lake. And so the other thing where we find calcite, predominantly calcite, is found in seashells of ocean or marine organisms. So when, let's say, a clam dies, that shell will slowly get dissolved away if it doesn't wash up on shore by the water. And that water is dissolving away that calcite, which has carbon in it, which is now in the ocean. Okay? Your ocean is the biggest reservoir for carbon. There is more carbon tied up in all of the ocean water on this world than there is in all of our living things on land. It is the biggest reservoir. The second biggest reservoir are sedimentary rocks. And all three of these are sedimentary rocks. Not the only ones that contain carbon, they're just some of the most popular. So remember that your reservoirs are long-term storage. Carbon is also stored in the atmosphere. What's the predominant storage molecule of carbon in the atmosphere? Carbon dioxide and methane, CH4. Methane's not as popular. It's also stored in living organisms. You have carbon in you. The grass does, the trees do, your dog does. And the third storage spot are in fossil fuels. Fossil fuels such as coal, oil, natural gas, wood. They all contain carbon. These are more short-term storage. And what do we call our short-term storage? In a fancy word. It's actually two words. The exchange pools. So if you think about it with these exchange pools, we have carbon. You have a bonfire. You're burning that wood. You are releasing carbon into the atmosphere. Okay? Now that atmosphere, that carbon in the atmosphere can now combine with oxygen to make carbon dioxide. Now the plants use carbon dioxide for photosynthesis. See how we went from fossil fuel to atmosphere, and now we're into a living thing because of a plant. And now you eat the apple that came from the apple tree, so now it's into you. We now have moved carbon from a piece of wood burned in a bonfire through the atmosphere to a plant to a human. That carbon has been transferred to all these different exchange pools. All right, so are there any questions about your carbon cycle here? All right, so kind of like we just said, carbon quickly cycles between organisms and the atmosphere. So remember, there's carbon dioxide in the atmosphere. The plants use carbon dioxide. That carbon now has moved from the atmosphere to the plant. Other animals eat plants, and now that carbon has moved to 3 different exchange pools. So we say photosynthesis happens. And this causes the carbon to come out of the atmosphere. We remove it, and then we use cellular respiration to return carbon back to the atmosphere. So every time you breathe out, you're pumping CO2 or carbon specifically back into the atmosphere. But then every time you eat something, you're eating something that took carbon out of the atmosphere. So it's this little cycle, like a carbon cycle. Imagine that. All right, the last one, ooh, at least I got one color right, is the nitrogen cycle. The nitrogen cycle moves nitrogen through abiotic and biotic parts of the ecosystem. 78% of your atmosphere around Earth is made up of nitrogen. There is more nitrogen than oxygen in the atmosphere. There is more nitrogen than carbon dioxide in the atmosphere. Nitrogen is found in proteins, nucleic acids, and chlorophyll. So the takeaway here is that all living organisms require nitrogen. You need nitrogen to build new DNA molecules. So if you want your cells to replicate, to replace old and dead ones, you want to make new DNA molecules. We need plants to have chlorophyll so they can do their photosynthesis gig. You need proteins so your DNA or your cells know what they're supposed to do, what their task is. So plants cannot use nitrogen gas as it's found in the atmosphere. I believe it's N2 that's in the atmosphere. They can't use it. It's not functional for them. So it has to be changed to the form nitrate. Plants can use nitrate. So we need a middleman to take the N2 from the atmosphere to change it to nitrate, which is NO3 minus, if you care. This process, this middleman of taking N2 into NO3 is called nitrogen fixation. I like to think of it as fixing the nitrogen for plants. It fixes it so they can use it. Okay? So this is the process of changing nitrogen gas into nitrate. And this is done by nitrogen fixing bacteria in the soil or in the roots of legumes. Legumes is a fancy word of saying beans. So when an organism dies, decomposers will break down the remains, right? Because that's what decomposers do. This process releases nitrogen back into the atmosphere. Nitrifying bacteria change it into nitrates to be used by plants. And then some is changed into nitrogen gas by denitrifying bacteria, and that's released back into the atmosphere. Ooh, I was right with the N2.